Vertex form. In this video, you'll learn how to recognize the vertex form of a quadratic equation. You'll also learn how to relate the numbers in the vertex form of a quadratic equation to its graph. So the vertex form of a quadratic is f of x is equal to a times x minus h squared plus k, where the coordinate of hk represents the vertex of the function, and a tells us the direction and the width of the parabola. So if we have a function like y equals x minus 4 squared plus 8, then our a value in this function would be 1. Since there's nothing in front of it, we can assume that they multiplied that by 1. So a is equal to 1, and we can see that h is equal to 4, and k is equal to 8. So we can tell that our vertex happens at the coordinate 4, 8, and the parabola will open upward since our a value is positive. Now if we have a function like y equals negative x minus 4 squared plus 8, now our a value is negative 1. So we'll put a as negative 1, h is still 4, and k is still 8. So the vertex will still happen at 4, 8, but since a is negative, our parabola will now open downward. Now let's look at this function of y equals x plus 10 squared. Our a value is the 1 that's there, so a is positive 1. And if we look at the value of h, instead of subtracting it, our equation is adding 10. So this tells us that h must have been negative 10, since subtracting a negative is the same as adding. Now if we look at k, we can see that there was nothing there, but this is still the same as adding 0. So our k value will be 0. So our vertex happens at negative 10, 0, and our value of a equals 1 tells us the parabola will open upward. In our last example, we have f of x is equal to negative 1/2 times x plus 3 squared minus 5. So our a value is negative 1/2. Our h value, again, is adding 3 instead of subtracting. So this tells us that h must have been negative 3. Now if we look at our k value, they're subtracting 5. So k will become negative 5 since they were subtracting. Now we can see that our vertex happens at negative 3, negative 5, and our a value of negative 1/2 tells us that the parabola will open downward. Let's look at a few more examples. We're going to show that the following equations are equivalent. So we'll start by expanding both functions and see if they simplify to the same equation. We'll start by distributing x to the parentheses, and this gives us x squared plus 6x. Now let's look at p of x. So x plus 3 squared is the same as multiplying x plus 3 by itself. So we'll distribute the first x plus 3 to the second parenthesis. This gives us x times x plus 3 times x plus 3 minus that 9. So we'll get x squared plus 3x plus 9 minus 9. We can combine our like terms of x by adding 3x and 3x, and we can combine our constant terms of positive 9 and negative 9. So this will give us x squared plus 6x plus 0. And now we can see that this matches our simplified version of m of x. So these are equivalent. Now we're going to find the x-intercepts and the vertex. We can see that m of x is in factored form, so this will be used to find the x-intercepts. We know that m of x would be 0 for finding the x-intercepts, so we can set each parenthesis equal to 0. X equals 0 is already solved, so we'll solve x plus 6 equals 0 by subtracting 6 on each side. This will give us x is equal to negative 6. So now we can see that our x-intercepts happen at 0 and negative 6. Now let's look at p of x to find the vertex, since this one is in vertex form. Vertex form is x minus h squared plus k, where hk is going to be our vertex. So in our example, we can see that h looks like it's 3, but since vertex form subtracts h and p of x in our case adds h, this tells us that the positive 3 would really represent a negative 3, since we subtracted a negative to get the positive that we have. And then we can see that k is negative 9. So our vertex happens at negative 3, negative 9. Let's look at another one. Let's write an equation that could represent this graph. Since we're given the vertex, we'll write this equation in vertex form. So we'll take our vertex form equation of y equals a times x minus h squared plus k. We can see that h is negative 3 and k is negative 1. So we'll put this into our equation. In our x term, when we subtract negative 3, it's the same as adding 3, so we can simplify that. And then when we add negative 1, it's the same as just subtracting 1. So now all we have left is our a value. Since our parabola is going downward, we can say that our a value is going to be negative 1. In this example, we're going to decide which functions are in vertex form. So as long as we can label the a, h, and k value, then we can consider these in vertex form. In our first equation, we can see that a would be 1, h would be 2, and k would be 1. So this one's in vertex form. And the one below it, we can see that a would be 1, h would be 0 since x is really adding nothing to itself, and k would be negative 4. So this one is also in vertex form. The one below it we can see is in factored form since they're multiplying two products. So this one would not be in vertex form. Now let's look at the one on the top. We can see that a would be 1, h would be negative 3, and k would be 0. So this one is in vertex form as well. And the last one has a value of 1, a h value of 4, and a k value of 6. So this is also in vertex form. In our last example, we're going to give the vertex for each equation. In our first one, we can see that h would be 3 and k would be 5. So our vertex happens at 3, 5. Now let's look at the one below it. We can see that h would be 4 and k would be 0 since we're not adding anything. So our vertex happens at 4, 0. Now let's go back up to the top. We can see that h would be negative 7 and k would be 3. So our vertex happens at negative 7, 3. Remember that if we're adding a number in the x term, that means that it would be a negative, since subtracting a negative makes it the plus sign that we have. In our last example, we have h and k, and we can see that h would be 0 since we're adding 0 to our x term, and k would be negative 1. So our vertex happens at 0, negative 1. Now let's summarize what we've learned. The vertex form of a quadratic of y equals a times x minus h squared plus k reveals important information about the graph, like the vertex, parabola opening, and transformations. The vertex hk represents the minimum or maximum point of the graph.